The signal that should not exist. There are moments in human history when discovery does not bring clarity, it brings disruption. Moments when something is uncovered that does not simply expand knowledge, but challenges the very structure of reality itself. This is one of those moments because somewhere in the depth of achieved space data, hidden beneath layers of cosmic noise, radiation, and static interference, a signal was found, not unusual, not immediately alarming, but impossible. A signal that should not exist. A signal that did not behave like anything we had ever observed before, and most disturbingly of all, a signal that appeared to know the future. Chapter 1. The first pattern in the void. The discovery did not happen in real time. There was no dramatic moment, no flashing alert across global systems. Instead, it began quietly, almost invisibly, inside a dataset that had been sitting untouched for years. The data came from deep space radio observation, originally collected to study cosmic background radiation, routine, unremarkable. But when new machine learning models were applied to the achieve, something unexpected emerged, a pattern, faint, almost indistinguishable from noise, but repeating, not randomly, not irregularly, perfectly, every 137 seconds. The number itself raised immediate attention. 137 is not arbitrary. It is intimately connected to one of the most fundamental constants in physics, the fine structure constant, a value that governs the interaction between light and matter at the deepest level. At first, scientists assume coincidence. Noise can sometimes mimic structure, but noise does not remain stable. Noise degrades, noise drifts. This signal did neither. It was consistent, precise, and more importantly, it was evolving. Chapter 2. Structure within the signal. When researchers isolated the signal from background interference, its true nature began to emerge. It was not simple repeating pulse. Each repetition contained subtle variation, tiny shifts in frequency, minute changes in amplitude, patterns nested within patterns, almost like layers of information stacked on top of each other, as if the signal was not just repeating, but building. AI-assisted decoding revealed the deeper structures, prime number sequences embedded in timing intervals, geometric ratios encoded in waveform curvature, frequency harmonics aligned with physical constants found across the universe. This was not natural, or at least it did not behave like any known natural phenomenon. It was structured, deliberate, intentional. But there was still no source, no star system, no pulsar, no artificial satellite. Nothing in the sky corresponded to its origin. The signal existed without a sender. Chapter 3. The impossible timeline. The turning point came when a researcher made a simple decision: compare the signal to older data sets. Not just recent data, but achieved records going back decades. The expectation was straightforward. If the signal was real, it should appear consistently across time, and it did, but not in the way anyone expected. In older data sets, the signal was shorter, less complex, less complete, as if it had been unfinished. But as the dataset became more recent, the signal grew, more layers, more structures, more information. The signal was not degrading over time. It was improving, but the direction was wrong. Instead of becoming more complex in the future, it became more complex in the past. Chapter 4. A paradox without explanation. This created a paradox that challenged everything. If the signal originated in the past, it should become more degraded over time. if it originated in the present. It should not appear in older datasets at all. But this signal did both. It existed in the past and it evolved toward it. The only explanation that fit the data, however impossible it seemed, was this. The signal was moving backward through time. Chapter 5. From anomaly to information. At this point, the investigation shifted. The signal was no longer treated as interference. It was treated as data. Researchers began decoding it not as a waveform, but as information. And what they found was far more disturbing than expected. Hidden with the structure were references, coordinates, energy signatures, temporal markers. When mapped against known cosmic events, the alignment was undeniable. Supernova, gamma ray bursts, gravitational wave detection. But these were not past events, they were future ones. Chapter 6. The first test. One even stood out above all the others. A distant star system predicted to collapse in a supernova. At the time the signal was recorded, no such event has been observed, no anomaly, no instability. Nothing to suggest imminent collapse, but the signal described it in detail: timing, energy output, radiation profile. 6 months later, the event occurred, exactly as encoded. Chapter 7. The End of Doubt. After that, skepticism began to collapse. This was no longer coincidence, no longer statistical anomaly. The signal contained future data, and that meant something far more profound than anyone was prepared to accept. Information was moving backward through time. Chapter 8. Theory collide. The scientific community fractured into competing explanations, each attempting to preserve the fundamental laws of physics. Some proposed closed time-like curves, loops in spacetime where cause and effect could not reverse. Others suggested quantum retrocausality, the idea that future states can influence past conditions at the quantum level. More radical voices introduced simulation theory, arguing that reality itself could be accessed non-linearly. But none of these explanations fully accounted for the scale, structure, and precision of the signal. There was always something missing, until one theory emerged that no one wanted to be true. Chapter 9. The Future Sender. The simplest explanation was the most disturbing. The signal was not natural, it was not random, it was not a glitch in physics, it was being sent from the future. Chapter 10. The second layer. Just as this idea began to take hold, researchers uncovered something even more settling. Beneath the predictive data, there was another layer. Hidden, subtle, encoded in variations so small they were almost invisible. The second layer did not describe cosmic events. It described Earth, atmospheric shifts, ocean temperature changes, energy pattern associated with human civilization. And then, something even more precise, marker aligned with technological milestones, developments that had not yet happened. Chapter 11. The Warning Hidden in the Future. At first, the second layer of the signal did not appear alarming. It simply existed beneath the predictive structure like a shadow behind a shape, something that could easily be overlooked if the focus remained only on a cosmic. Chapter 11. The Warning Hidden in the Future. At first, the second layer of the signal did not appear alarming. It simply existed beneath the predictive structures like a shadow behind a shape, something that could easily be overlooked if the focus remained only on cosmic events. But once researchers began isolating it with higher precision filters, the tone of the investigation changed completely because the layer did not behave like the rest of the signal. It was less mathematical, less abstract, and far more specific. It described Earth not as a point in space, but as a dynamic system, an evolving environment filled with variables that shifted over time. And within those shifts were patterns that aligned with human activity, energy consumption spikes, atmosphere composition changes, oceanic thermal variation, and even electromagnetic disturbances linked to technological development. But what made this layer different was not just its content, it was its structure, because unlike the rest of the signal which described events as fixed sequences, this layer branched it. Is split into multiple pathways, each representing a different possible outcome. And those outcomes were not random. They followed decision points, moments where small changes could lead to dramatically different futures. And when those branches were mapped into a timeline, something became clear that no one had expected. The signal was not simply predicting what would happen, it was mapping what could happen. And within that map were scenarios that ranged from stable progression to catastrophic collapse. Climate thresholds crossed, energy system destabilized, planetary scale disruption triggered by seemingly minor shifts, and yet none of these were presented as certainties. They were possibilities, weighted, structured, interconnected, and this introduced a new idea that was far more unsettling than the concept of a signal from the future, because it suggested that the future itself was not fixed, it was conditional, and the signal was showing those conditions as if they were already known, as if somewhere at some level beyond human perception, every possible version of what could happen had already been calculated and words observed. And within that realization, a new interpretation emerged, one that shifted the entire meaning of the signal. It was not broadcast, it was a warning, but not a warning in the traditional sense, not a message that said do this or avoid that, but something far more complex. It was a system that revealed consequences, that exposed the fragile chain of cause and effect that connected every action to its outcome. And the deeper researcher went into this second layer, the more they realized that the signal was not trying to tell humanity what to do. It was forcing humanity to understand what its choices meant. And that understanding came with a weight that could not be ignored, because for the first time, the future was no longer something unknown, it was something partially visible, something that could be examined, explored, or even influenced, and that changed everything. Because once you see a possible future, you cannot unsee it. And once you know that different outcomes exist, you began to ask a question that had never truly been asked before at this scale. Not what will happen, but which future are we moving toward right now? And more importantly, can that path be changed? Chapter 12. The first human response. The decision to respond to the signal was not immediate. In fact, it was resisted for as long as possible because the implications were too uncertain, too dangerous. If the signal truly originated from the future, then any interaction with it could create feedback loops that no one fully understood. Loops that might reinforce certain outcomes or erase others entirely. But eventually, The pressure to act became too strong to ignore because observing the signal without responding meant accepting a passive role in a system that was clearly interactive. And so a controlled experience was designed, not to send a message in the traditional sense, but to mirror the structure of the signal itself, to create something that could be recognized within its own language, a sequence of mathematical constants, prime number progression, and harmonic ratios that match the underlying patterns already detected. The idea was simple. If the signal was capable of carrying structured information across time, then perhaps it could also recognize structures sent back into it. And the transmission was executed using synchronized global arrays, a coordinated effort that ensured the signal would be broadcast with maximum clarity and precision. And for a moment, the world waited, not with excitement, but with something closer to tension, because this was not like sending a message into space hoping for a reply from another civilization. This was different. This was an attempt to communicate with something that might already know the outcome of that communication. And the waiting was long, longer than expected. Days turned into weeks, and nothing happened. No immediate change in signal, no visible reaction, and for a brief period, it seemed as though the attempt had failed. But then something subtle occurred, something so small it was almost missed. Within the signal, one of the branching sequences shifted, not dramatically, not in a way that would immediately draw attention, but enough that it no longer matched previous models. And when researchers analyzed the shift, they found that it aligned with the exact structure of the response that had been sent, not as a direct reply, not as a mirrored signal, but as an integration, as if the signal had absorbed the response and incorporated it into its own framework. And that was the moment everything changed, because it proved something that had only been theoretical until then. The signal was not a fixed transmission from the future. It was dynamic. It could be influenced, and that meant the future itself might not be a single determined path, but a system that responded to interaction, a system where past and future were not separated, but connected in a loop of continuous influence. And this realization carried both hope and danger, because if the signal could be influenced, then perhaps catastrophic outcomes could be avoided. But at the same time, it meant that every action taken without full understanding could create consequences that were impossible to predict. And from that point forward, the study of the signal was no longer just a scientific investigation. It became something far more complex, a balance between curiosity and caution, between the desire to understand and the fear of what that understanding might change, because the signal had revealed something that humanity had never truly confronted before. And the future might not just be something we move toward, but something that moves in response to us. And once that the door is opened, it cannot be closed again. Chapter 13. The first paradox emerges. The moment the signal changed in response to humanity's transmission, a new question emerged, one that no model could comfortably answer, one that no equation could fully contain, because for the first time, cause and effect were no longer clearly separated. And within the updated signal structure, researchers noticed something that should not have been possible, a sequence that appeared before it had been transmitted. A fragment of the response that had only been sent days early was now present in older layers of the signals, layers that existed in a cheap dataset from years ago, and at first this was dismissed as misalignment, a synchronization error, a glitch in the reconstruction process. But repeat analysis confirmed the same result. The response was not only being perceived, it had been retroactively embedded into the signal's path, as if it had always been there, and this created a paradox that struck at the very core of logic, because if the signal in the past already contained the response from the present, then the response had not created the chain, it had fulfilled it, and that meant the action taken by humanity was not a new event, it was part of the loop, a closed system where future and past were not sequential but interdependent. And within that realization came a deeply unsettling implication that free will, at least in this context, might not be entirely free, because the act of responding to the signal had already been encoded within the signal itself, not as a prediction, but as a necessary component of its existence, and this blurred the boundary between discovery and participation in a way that made it impossible to tell where human decision embedded and the signal's influence began. Because if the signal contained information from the future, and that future included the decision to respond, then the signal had always been contained the response, and the response had always been inevitable. And in that moment, the investigation crossed a line that could not be uncrossed, because it was no longer about understanding an anomaly, it was about confronting a system where time itself behaved as a loop, not a line, and where every attempt to interact with it might already be part of its structure. And the more researchers examined the data, the more they found evidence of this loop, fragments of future actions appearing in early layers, patterns that only made sense when a decision had been made, as if the signal was constantly adjusting its own path to remain consistent with an unfolding present. And that consistency came at a cost, because it meant that the signal was not just observing reality, it was maintaining it ensuring that every branch, every outcome, every action aligned within a coherent framework. And that framework did not allow contradiction, it absorbed them, corrected them, regrowed them until everything fit. And once that became clear, the nature of the signal shifted again. It was no longer a messenger. It was a system of continuity, a mechanism that preserved that integrity of a timeline that was no longer linear. And within that system, humanity was no longer outside. Looking in, humanity was part of the loop, part of the structure, part of the equation that could not be solved without including itself. Chapter 14. The Consequence of Interference. As the reality of the loop began to settle, a dangerous idea took hold among certain research groups, an idea that seemed logical at first, but quickly revealed its complexity. If the signal contained multiple possible futures, and if interaction with it could influence which part became real, then perhaps it was possible to guide outcomes, to select better futures, to avoid catastrophic ones. And this led to a series of controlled interventions, small, precise attempts to alter specific predicted events. The first of these interventions targeted a relatively minor anomaly, an energy fluctuation in a remote region that the signal indicated would escalate into a larger disruption. The plan was simple. Introduce a change in the system early enough to prevent the escalation, and initially it appeared to work. The predicted outcome did not occur. The fluctuation stabilized, and for a brief moment, it seemed as though the signal had been successfully influenced in a beneficial way. But then something unexpected happened. A different event emerged, not in the same location, not even within the same system, but connected through a chain of dependencies that had not been fully understood. The new event was more severe, more complex, and more difficult to contain, and when the signal was analyzed again, it became clear that the original branch had not been eliminated, it had been replaced, shifted into another pathway that carried its consequences in different form. And this revealed that something fundamental about the future of the signal. It did not outcomes to simply disappear, it redistributed them, maintaining balance across its network of possibility. And this meant that intervention was not removal, it was transformation, and every attempt to prevent a negative outcome could result in the creation of another, equally significant but less predictable consequence. And as more interventions were attempted, the pattern became undeniable. The system resisted optimization, not by blocking change, but by adapting to it, ensuring that the overall structure remained consistent. And this introduced a new level of complexity, because it meant that the signal was not guiding humanity toward a specific future. It was preserving a few possibilities where no single part could dominate without affecting others, and within this field, every decision carried weight beyond its immediate context, influencing not just one outcome, but the entire network of potential outcomes. And the realization of this interconnectedness forced a shift in perspective, because it became clear that the signal was not a tool for control. It was a system that revealed the limits of control, a system that showed how deeply connected every action was to every possible future, and how impossible it was to isolate a single outcome without affecting the whole. And this understanding brought with it a new kind of caution, one that was not driven by fear, but by awareness that the future was not something that could be engineered with precision, but something that emerged from a complex web of interaction, and that web extended far beyond what any single model could fully capture. And as the implication of this became clearer, the question shifted once again, from how do we change the future to should we even try? Chapter 16. The moment reality started to shift. At first, the changes were so small that no one was willing to call them what they were, because to do so would mean accepting something that lay far beyond any existing framework of science, something that did not just challenge theories, but dissolve them entirely. The measurements began to drip, not randomly, not chaotically, but in patterns that align with the internal structure of the signal. Atomic clocks, systems designed to measure time with near-perfect precision, began to fall out of sync by fractions so small they would normally be ignored. Yet, those deviations were consistent, repeating, structured, and when those patterns were mapped against the signal, the correlation was undeniable. It was as if time itself, at least at the level of measurement, was being subtly adjusted, not broken, not reserved, but nudged, guided in ways that mirrored the branching pathways embedded within the signal. And at first the assumption was error, calibration drift, environmental interference. But when isolated systems, completely disconnected from external networks, began to exhibit the same behavior, the possibility of coincidence collapsed, and what remained was something far more unsettling. Reality itself was beginning to reflect the structure of the signal, not as a passive recording, but as an active system, a system where measurement and outcome were no longer independent. And this realization spread slowly through the research community, not because it was difficult to understand, but because it was difficult to accept, because the signal was influencing the fundamental consistency of time measurement. Then it was no longer confined to data. It was operating at the level of physical reality, and that meant the boundary between observation and existence had been crossed, not gradually, but decisively. And once that boundary is crossed, there's no returning to the assumption that reality is fixed, because it becomes clear that what we perceive as stable is only stable within certain limits that the signal was now beginning to reach, and as more systems were analyzed, the same pattern appeared again and again: small shifts, precise adjustments, deviation that align not with randomness but possibility, as if the system was exploring its own pathways, testing different configuration of outcomes in real time. And the deeper researchers looked, the more they began to suspect that what was happening was not a breakdown of reality, but a transition, a movement from one mode of existence to another, from a fixed linear timeline to something where multiple potential states could coexist, overlap, and influence each other. And within that transition, humanity was not just observing the change, it was experiencing it. And that experience came with a growing awareness that signal was no longer something external, it was something embedded, woven into the very fabric of how events unfolded. And once that realization took hold, the question was no longer whether the signal was real, but whether reality, as it had always been understood, was never truly separated from it. Chapter 17. The first event that should not have happened. The confirmation came not through theory, not through simulation, but through an event so precise, so impossible, so simple, that it forced even the most skeptical minds to reconsider everything they believed about causality. The experience itself was simple, designed intentionally to minimize variables, a control system in which a sequence of random outcomes was generated using quantum-level processes, systems that by definition produce results that cannot be predicted or predetermined. And the purpose of the experiment was not to control the outcome, but to observe whether the signal's influence could be detected within it. And for several trials, nothing unusual occurred. The result followed expected distribution. Randomness behaved as randomness should. But then, in a signal trial, the sequence aligned perfectly with a predicted branch from the signal, not approximately, not within probability, but exactly, a sequence of outcomes that should have had near zero likelihood occurred in precise order, matching a future pathway that had been identified. But exactly, a sequence of outcomes that should have had near zero likelihood occurred in precise order, matching a future pathway that had been identified within the signal structure. And the room fell silent, not because the result was dramatic, but because it was undeniable. This was not prediction, this was alignment. The system had not guessed the future, it had selected it. And the distinction between those two ideas was profound, because the prediction implied observation, while selection implied participation, and this meant that the experience had not simply reviewed information, it had interacted with the structure of possibility itself, collapsing one branch into reality while excluding others. And as more trials were conducted, the pattern repeated, not consistently, not predictably, but often enough to establish a connection. The signal was not controlling outcomes, but it was influencing probabilities, guiding system toward certain configuration without eliminating randomness entirely. And this subtle balance was perhaps the most important discovery of all, because it suggested that the signal was not overriding reality, it was shaping it, working within its rules while extending its boundaries. And within that framework, the idea of randomness itself began to shift, because it suggested that the signal was not overriding reality, it was shaping it, working within its rules while extending its boundaries, and within that framework, the idea of randomness itself began to shift because its outcomes could be influenced at the level of probability. Then randomness was no longer purely random. It was conditional, responsive, and connected to a larger system that existed beyond immediate observation. And this realization carried implications that extended far beyond the laboratory, because it suggested that every event, every decision, every moment of uncertainty might be a part of a broader structure, a structure that the signal was revealing piece by piece. And as that structure became clearer, the nature of reality itself began to change, not in a visible, dramatic way, but in a subtle, pervasive shift that altered how events were understood. Because once it becomes clear that outcomes can be influenced by something that exists beyond the present moment, the concept of causality is no longer absolute. It becomes flexible, dynamic, part of the system where past, present, and future are not separate stages, but interconnected states, constantly interacting, constantly shaping each other. And within the system, the event that should not have happened was not an anomaly, it was a glimpse, a brief moment where the underlying structure of reality revealed itself. And unseen, it could not be unseen. Chapter 18: The Signal Inside Human Decision. As the experience expanded beyond isolated systems, attention turns to something far more complex, far less predictable, and far more significant: human decision making. Because if the signal could influence probabilistic, then the question naturally arose: could it also influence the choice made by conscious being? And this question was approached with caution, not only because of its implication, but because of the difficulty in measuring it. Human decisions are not easily reduced to variables. They are influenced by emotion, memory, perception, and countless other factors. And yet, within cultural environments, patterns begin to emerge. Subtle correlation between decision outcomes and pathways identified within the signal, not in a way that suggested control, but in a way that suggested alignment, as if certain choices were more likely to occur when they corresponded to specific branches within the signal structure. And this did not mean that individuals were being forced to act in a certain way. Rather, it suggested that the conditions under which decisions were made could be influenced, that the probability of choosing one option over another could be slightly adjusted. Not enough to eliminate free will, but enough to guide it. And this distinction was critical because it meant that the signal was not overriding human agency. It was interacting with it, operating at a level where choice and probability intersect. And this intersection is where some of the most profound questions in philosophy and science converge, because it challenges the idea that decisions are entirely self-contained, suggesting instead that they may be a part of a larger system of influence, a system that extends beyond the immediate context of the individual. And as more data was gathered, the pattern became clearer. Decisions that aligned with certain branches of signal tended to produce outcomes that reinforced those branches, creating feedback loops where choice and consequence became increasingly interconnected. And within the loops, the signal's influence became more pronounced, not as a force, but as a tendency, a directional bias that nudged system toward specific configuration. And this raised a question that was both fascinating and unsettling. If decision can be influenced at the level of probability, then how much of what we choose is truly independent, and how much is part of a larger pattern that we are only beginning to perceive? And why there was no definitive answer. The implications were impossible to ignore because they suggested that the signal was not just a map of the future, it was part of the process by which the future is formed, interacting with systems at every level, from quantum events to human choices, weaving them together into a structure that is far more complex than any signal perspective can fully capture. And within that structure, the line between observers and participants becomes increasingly blurred, because to observe the signal is to interact with it, and to interact with it is to become part of the system it represents. Chapter 19: The breakdown of cause and effect. As more data accumulated and more systems were tested, a realization began to form that was far more difficult to accept than any previous discovery, because it did not just challenge a specific theory or model, it challenged the very foundation upon which all scientific reasoning had been built. The idea that cause precedes effect, that event follows a sequence where one leads to another in a clear, traceable order, but within the structure revealed by the signal, that sequence began to blur, and then, in certain cases, it seemed to disappear entirely. Experience designed to track causal change, where a specific input should produce a specific output, began showing inconsistency that could not be explained by error or noise. Outcome appeared before the conditions that should have produced them were fully established. Decisions seemed to align with consequences that had not yet been realized, and in some cases, data logs show traces of results that only made sense after an experience had concluded, as if the outcome had influenced the process that led to it. And this was not a one-time anomaly. It was a pattern, subtle at first but increasingly clear, and as researchers attempted to model this behavior, they found that traditional linear framework could not accommodate it, because the framework relies on a strict direction of time, a forward flow where the past determines the present and the present determines the future. But the signal operated outside of that constraint. It treated time not as a line but as a network, a structure where points could influence each other regardless of their position along a timeline. And within that structure, cause and effect were not separate stages. They were aspects of the same system, interacting in ways that made it impossible to assign a single direction of influence. And this realization had profound implications, because it meant that the future was not just a result of the past. It could also be a contributor to it, that events might not simply unfold but coexist in a state of mutual influence. And while this idea had been explored in theoretical physics, particularly in discussions of quantum mechanics and retrocausality, it had never been observed at this scale, never demonstrated in a way that connected abstract theory with measurable reality. And yet here it was, emerging from the structure of the signal, not as an isolated phenomenon, but as a fundamental characteristic of the system. And as this understanding deepened, the language used to describe it began to change. Words like before and after lost their clarity, replaced by terms that emphasize relationship rather than sequence, interaction rather than progression. And within this new framework, the question was no longer what caused what, but how different states of reality influence each other across time. And that shift in perspective marked a turning point, because it meant that the investigation was no longer about discovering how the signal worked. It was about redefining how reality itself is understood, and within that redefinition, the most unsettling idea of all began to take shape, and that the distinction between cause and effect might not be fundamental, but emergent, a construct that arises from limited perception, rather than a rule that governs the universe at its deepest level. Final chapter. The signal was never sent. By the time the investigation reached its final stage, there was almost nothing left that could be considered there was almost nothing left that could be considered certain, not the origin of the signal, not its purpose, not even the assumption that it existed as something separate from reality itself, because every layer that had been uncovered, every theory that had been proposed, every experiment that had been conducted had led to the same conclusion, a conclusion that was as simple as it was unsettling. The signal was not something that had been sent from one point in time to another. It was something that existed across all points at once, not traveling through time but embedded within it. And once that idea took hold, everything began to align in a way that made the earlier paradoxes no longer seem like contradiction, but like necessary features of a system that had always been operating beyond linear understanding. The signal did not originate in the future. It did not originate in the past. It did not have a beginning or an end in the way that human concept of time requires. It was a structure, a field, a framework that contained within it all possible state of reality, and within that framework, information did not move forward or backward. It simply existed, accessible from different points depending on how it was observed, and this explained why the signal appeared to evolve backward through time, why responses seemed to appear before they were sent, why outcomes could influence the condition that produced them, because from the perspective of the signal, though distinction did not exist, past,